All right, so next up is where do I inject my samples? We now know that the carrier gas's purpose is to flush through the machine and carry my sample through the instrument. But where on earth do I inject the sample in the first place, right? That's always the question with any type of machine or instrument that we use in the laboratory. Okay, so if I go back to the drawing of the GC, and I've cleared it out here, so I'm just going to draw a small one up here at the very top. We wrote the helium tank over here to the side, and we said the helium tank goes through a filter and it goes into the machine. Well, we've always pointed that piece of tubing toward the injector site, which is right here on the instrument, typically on the very top. It's easily accessible, so that way you can insert your sample there at countertop level without a problem. The helium goes into that injector and it mixes with your sample in that injector. So this is what our focus is going to be on in this particular video. It's going to be the injector itself, right? How is it made? What are the pieces and parts inside of the injector that makes it work? And what to do if it begins to tear up or if I have to replace it. So, three things that you need to know when it concerns the actual injector itself. Number one is that it has to vaporize your sample. We've always said that samples in a GC have to be turned into a gas. So, in order for it to turn into a gas, we're going to have to heat the sample up. And that means that the injector has a heat or a temperature setting. This is something that I will have to make sure of before I start the actual running of a sample in the very beginning of my analysis. I have to make sure that the temperature on my injector is set at the proper degree Celsius. You know, this is kind of like you cooking in a kitchen. Before you bake a cake, you want to make sure that that temperature is the proper temperature that you should bake that cake at. All right, well, injectors are the same way. You have to make sure that the temperature here is the proper setting for the type of sample that you're running. So number two, other than vaporization, what else does it need to do? Well, it has to be able to mix. Well, what is it mixing? It's mixing your sample with the mobile phase. And that mobile phase is my carrier gas, and that carrier gas is probably helium. So it's got to heat my sample up to turn it to a gas. It's got to provide some kind of outlet or chamber in order for me to mix my sample with the carrier gas. And that way the carrier gas can carry it on into the instrument itself. And number three, we say bring about. Now, what does this actually mean? Well, bring about really means take it into the column itself. So once it heats and turns it into a gas, once it mixes with my carrier gas, which is helium, then those things have to mix together, and I have to be able to inject it into the column itself. And the column, of course, was this piece on the inside that circles round and around and around before it comes back out. So it has to be able to take it into that column for it to do its job, right? Now, there's different detectors that are out there. And there's different ways that the injectors do all three of these things, but that's okay. They all three do these in some form or in some fashion. All right? We will see some of those differences a little bit later, but for now, these are the three that we want to focus on. What else about the injector? Okay, well, if this is the place that I inject my sample, then the next question is how do I get it in the injector? And to get it into the injector, you typically start with a syringe. These are normally Hamilton syringes, and Hamilton syringes are just kind of the standard that everyone really uses. But a Hamilton syringe is just really a needle. And just like if you were a nurse sucking up some medication, you pull up a certain amount of sample into the syringe, and then you inject it into the injector port, and then you're ready to inject your sample and run the analysis. How much sample do I need to put into that injector for this machine to work? Well, the question is that depends on your method, but ideally 1 to 20 microliters of sample. All right. Now imagine a 2-liter bottle of soda. 2 liters. All right. Now you're going to take half of that. That's 1 liter. Now that half, you're going to divide that up into 1,000 parts. And 1 little square is going to be a milliliter because we divided it up into 1,000 parts, right? All right, well, milli and micro are 3 orders of magnitude different from each other. So that means if I take that 1 little square and I divide that square up into smaller pieces, then we get 1 microliter. Microliter is basically the liter not divided up into 1,000 parts, but divided it up into 1,000,000 parts. That's pretty crazy when you sit back and think about it. So anywhere between 1 microliter, 1/1,000,000th of a half of a 2-liter soda, to 20 microliters is perfectly enough for the machine to do its job and to report some data. Okay? Sometimes people don't use the word injector. Sometimes they decide to be a little bit fancy. But the injector term can also be called a flash vaporization chamber or port. Don't ask me why some people use that. I guess they want to sound smart and they use flash vaporization port instead of just injector, right? But that's basically all that it does. It vaporizes, it mixes, it brings it to the column, and in order to get the sample into the injector, you're going to have to use a syringe that will hold anywhere between 1 to 20 microliters of sample. Okay. Now, with the syringe itself, I'll show you a picture of one of the syringes. Here, we've got someone that has a sample over here to the side, it looks like, and they've pulled some of the sample up into the syringe, which is here. This guy is injecting it into the injector port, which is right up here on the very top. And then his finger is going to push the plunger down on the syringe in order to squirt the sample into the machine itself. So that's a picture of someone actually injecting a sample onto the instrument itself. Here is maybe a better view of the syringe. Now, these will come in different forms and different sizes, but they're all basically the same thing. You see some type of syringe with graduated markings on it. The graduated markings are typically in microliters. Sometimes they'll put milliliter on there, but very rarely. And then up here at the very top is your syringe plunger. So this is what you would push down or pull up, depending on if you were sucking sample up in the syringe or pushing sample back down into the instrument. Another drawing that I've got to do, just so that kind of you understand how the injector port is made. We see the injector port here, and we get this syringe that gets punctured from the top, and it goes into the actual instrument itself. All right, so this is my injection port, and this is my syringe that's graduated, tick marked, that's got my sample, and I've shot it basically into the injector port. There's a piece right in here that prevents my sample, because once my sample goes in, my injector port is going to make sure that it's a gas. And the very last thing that I want to do is to see my sample leave the injector port and come out of the machine. I don't want that to happen. So what they do is that at the injector site, they put a small piece of rubber. And this small piece of rubber prevents this plug, prevents the sample from leaving the injector port and coming out of the machine. So this small piece of rubber we have a special term for, and this term is pretty important because we talk about it all the time, and it's called the septum. And that septum has to be replaced. We typically say that the replacement on these is anywhere from 50 to 100 injections. So an injection counts as any time the syringe punctures that septum to go down into the machine and squirt a sample, right? Even if it's a blank, we still count that as an injection. Over time, what happens is that this syringe keeps piercing that piece of rubber over and over and over and over and over. And over a course of time, this this syringe or the septum for the syringe will get worn out and it could become dry rotted or it could flake off. And you don't really want that to happen, right? So you want to make sure that this piece is fresh. You want to make sure that that piece is not used over and over and over so much that it's falling apart. And these are pretty cheap, right? They're very low in cost. It's not a problem to replace those every 50 to 100 uses, and it's very easy to do it with. So that's what we call the septum, and it just really helps prevent the sample from escaping on us, right? If I go back to the slideshow, here up at the very top, you'll see someone else injecting a sample with a syringe. There's an injector port. And this also looks like another injector port. So this is one of those GCs that have a dual injector and probably two columns up underneath the GC system itself. The syringe is held by one hand, and you always want to make sure that you've got one finger on top of the needle itself, because if you don't, this thing can build up pressure, and this will skyrocket out of the syringe, and you don't want that to happen. Down here at the very bottom, you'll see different types of syringes, different sizes of syringes. They're made different. Nothing really too special about either one of them. It just really depends on your sample type and how much you actually have to inject. And that determines what type of syringe that's going to be best for you. Okay. These syringes are also very important. You have to make sure that these syringes stay clean, right? That's the problem with the syringe. You want to make sure that it stays clean, and if you do not clean them before and after, you will actually seize the needle up, and you could destroy the needle, and we can't use it anymore. Cleaning it also prevents cross-contamination. So, one, you're ensuring the life of the syringe when you clean it. And number two, you are also preventing contamination. You don't want that to show up in your chromatogram. How do we clean it? Well, we clean it with acetone or we clean it with methanol. And I'm going to abbreviate methanol, MEOH. So those are the two choice of solvents. You literally just keep pulling acetone up in the syringe and squirting it out, pulling new fresh up, squirting it out, and you do methanol the same way. Fill the syringe full 7 or 8 different times, and make sure that you're really flushing everything out of there and having a clean syringe both before and after use. That way, when someone else comes behind you and uses it, they don't have to throw this $500 syringe away and get another one. So that's the biggest drawback with the syringe. These things are kind of costly. And you don't want to throw those away every week or every other week if it just simply requires you changing out some solvent, flushing it with some acetone or some methanol, and that's about it. So please keep that in mind when you use yours. Please keep that in mind whenever you have a Hamilton syringe in your hand, because that's pretty important, right? Okay, so in the next video, we'll continue on with the idea of septum. I'll show you what some of these look like, and we might take a closer look at some more syringes.